Okay, for the first segment of today, I will be introducing what these kind of functions are, and in particular on how to sketch the graphs first before we link it into the functions chapter. Okay, so first thing that we should know is something like fx here, where they tell you that you have this particular relationship. You're going to see that there is a plus a occurring on the either right-hand side of the equation or on the left-hand side of the equation. They will be telling you fx is fx plus a for all possible x values. Now, if something like that happens, I give you what is the thing that you need to know first before we see why. This will be called the period, the graph. The a value that you see is the period. And period refers to the graph will repeat itself for every a units. So every a units, like your trigo graph, every 2 pi, you're going to see the same graph. Okay, so why is that so? Let's try to explain with a small example below. In my particular equation here, I have got two equations. So functions like this look a little different in the sense that actually you have this particular equation defined from 0 to 4. I also have this equation that is defined from 4 to 5. So they are defined on different values. But first thing we should note that the total number of units that appear is actually 5 units. So the graph has got equation defined for the first 5 units from 0 to 5. And in addition, when something like that happens, it's likely that they tell you fx plus 5 equals to fx for all real values of x. So what is this 5 referring to? This is the period of the graph, the period of your fx function. But at this point, it may not be clear to you. Now, why is this the period? How does this imply that it's going to repeat? So we try to look at what happens if I were to substitute, let's say, the value 0. If we substitute two values for us to understand the equation. If I were to put 0 to this equation, let's write out what happens to the left and right. So on the left-hand side, you would have f of 5. Right-hand side, you would have f of 0. So it is trying to tell us that the x value at 5 and the x value at 0, they have got the same y value, the same f. So what is that y value? If I were to put 0 into the top piece equation, this will give me 1 over 1 plus square root 0, which is 1. Why are we putting it to the top piece equation? It's because 0 is defined on the top piece. X is inclusive at 0 for the top equation. So let's do one more round. Can I put this value 5 into that equation here? And I want to observe what happens. So this top equation now becomes F10 is F5. And I know what is F5. F5 is the value 1. So to understand this, can I just draw for you a very, very small graph here? We try to get the setup understood. What we currently can see from the current equations are at the values of 0, 5, and 10. We have got the y values known. So when it's at the value 0, we know that the y value is at 1. At the value 5, I know that it's also at the same point, 1. At 10, I also know that it's at the same point again at 1. So what we are trying to observe here is we can see that every 5 units, we have got the same y value. At 0, at 5, at 10, all of them are referring to the same y value. So what's the implication of knowing that every 5 units you have got the same y value? It means that the graph repeats every 5 units. So with this, they then have a common problem type where the question is going to look like this structure. They say, can I find what is f of the value 24? So let's try to find out what this number is. I know that the value 24 doesn't fit into any piece domain. It is our domain, the x values. It doesn't fit anywhere. So you have to try to reduce this number, and I can subtract 5. Even though the equation given was a plus 5, we understand that every 5 units is the same y value. So 24 and 19 has the same y value. I can continue to do this. We keep subtracting 5 until you get a number that is inside the domain. So 24 gets to 19, 14, 4, 9, and eventually 4. So once we get to the value 4, you take the value 4, you check which equation does it belong to. It belongs to the second equation here. So f of the value 4 will therefore be minus 1. We try to reduce that number so that we get to a number that is inside the current. So let's do the second one together. 30. When it's f of the value at 30, you then get f of 25. Keep going, 20, 15, 10, 5. If we write it in the long way first, I will show you how we can shorten the solution in a while. But 5 is still not sufficient because at 5, it wasn't defined. So we should not do 5. We should go one more round to go to 0. It's only defined at 0. It's not defined at 5. So this should have one more, we get to 0. Okay, so I have 1 over 1 plus root 0, which is the value 1. Okay, 0 is defined on the top piece, so you substitute to the top piece. Okay, then let's think about, you don't want to keep writing this in the exam. Is there a shortcut for us so that I can get to the last number very, very quickly? So one of the techniques that you should know is, let's say you want 24. How do I get to 4 quickly? 30, how do I get to 0 very quickly? What is the relationship? I don't want to keep subtracting 5. So the better way for us to do this is you think about, you take 24. I'm going to divide by the period for which we know that the period is 5. I divide by 5, but I don't want the value. I'm looking for the remainder. Effectively, if you keep subtracting 5 and you get to the last number, that number is the remainder of the equation. So the remainder here is equals to 4. And therefore, F24 will be the same as F4. On the right, similar. We take the value 30, we divide by 5. What is the remainder? Remainder is 0. So F30 and F0 will be the same. How is this useful? It's because sometimes they give you a very large number. I just give you something additional to this. They like to give you the year number, for example. So F2025. I can immediately just say that this is F0. Because I know that the remainder of 2025 divided by 5 is 0. There's no remainder. So straight away we get F0 and I can then quote this number is 1. Okay, so that is for the purpose of trying to find these two numbers. Now let's talk about how to get this graph drawn. I have the screenshot here of what happens to the two pieces. Let me just orientate you a little. Later, we will go through what to press on the graphing calculator. So on my top graph, this is defined 0 to 4. So 0 to 4 is actually this first piece. But to be clear, you should always take note whether you include or exclude at the endpoints. So this is inclusive at the end on the left. It's exclusive at 4. What this means for us is later when we draw, I just put it onto that screenshot first. You want to include the point at 0, you put a solid dot. If you want to exclude the point at 4, you put an open circle. So it should be inclusive at 0 and exclusive at 4. However, for the second equation, 4 to 5, you are including at 4 and excluding at 5. So it should be a solid here and an open later. Add the value -1. Can we try to draw this out together? Let me just shift my solution down. You help me construct a big set of axes. We're going to get the graph drawn out nicely. Okay, they want us to draw for a very big portion. We are supposed to draw from -5 to the value 12. So can we get this whole thing drawn out together? Okay, your y and x. For the first piece of the graph, we know that it's going to have, it starts from 0 and it ends at 4. So when I draw it out, I will need to mark out that the first graph ends at 4, and we will continue to 5 for one whole graph. I need to know also what happens at the start and at the end point for 0 and 4, because I need to indicate the end values. So we will sub 0 and 4 to the top piece. I want to know the top piece equation, what is the starting and end y value. Now when it's 0, the y value is at 1, if I sub in 0. If it's 4, your y value will be 1 over 1 plus root 4, which is 1/3. These are the two end values of my top piece graph. So when I draw out, can I just draw it slightly off scale a little so that I can show you the features better? Highest value is at 1, lowest value is at 1/3. We would like to draw the equation based on what you see from that screenshot on the GC. And it's going to end here. This is at 4. Inclusive at 0, you have to indicate with a solid dot. Exclusive at 4, open circle. You have to indicate that the last ending position is at 1/3, so I will draw a dotted line to try to match and show that it's ending at 4 as well. Now the other one that we would like to draw is -1, and -1 is from 4 to 5. So I will indicate where is -1 on the graph. So nothing to check on the y values, everything is at -1. So we draw a horizontal straight line at -1. This is from 4 to 5. Always check, do you include or exclude that value? We are including at 4 and excluding at the value 5. And I can also connect up this way. This is for one cycle. One cycle means 0 to 5. What do we know about this kind of graph? It's a period of 5 units. It's going to repeat, it's a cycle. So we will draw in the repetition. How much do you want to draw? They want you to draw all the way from -5 to 12. Now we will plan out slowly. Let's go for the next segment. After 0 to 5, we can go for 5 to 10. Every cycle is 5 units. And I know that the first stretch of the graph is 4 units. So the first stretch will be 5 to 9. Let's draw in 5 to 9. But to guide the graph nicely, I will suggest you should draw in a horizontal dotted line at the lowest and at the highest segment of each graph in this manner. Okay, so my first segment, highest at 1, lowest at 1/3. Draw a dotted line across left and right actually, because you want to guide your graph nicely. We want to get the shape perfect. Lowest possible position, I would do the same. So lowest possible position is at that -1. Okay, so I will draw in the horizontal line to match. Get the repetition done. You will copy and paste exactly the same graph, even including the dots. So when I draw out each segment, I will be sure that each segment we draw a dotted down to indicate there that this is the starting position is at 5 and it's ending at 9. We want to be very, very clear on where is your start and end. You draw dotted lines to the axis. Now 9 to 10, similar. You have this and we want to draw in the horizontal graph. We don't want to stop at 10. The question says we continue to 12. So I will continue with 2 more units up to 12. So 12 will not be a full cycle. There's only 2 units here. I know that one full cycle from the front is 4 units. Hence, the graph starting from 10 will stop abruptly at a particular value which we will find out. Okay, so at 10 it's here and at 12 we are stopping here. Let's finish here first. What is the end point of this graph? Endpoints, you have to indicate the value. So I'm trying to find out what is F12. For which F12 is F7, which is F5. We keep F2, we keep subtracting 5 to the X value. And F2 belongs to the top piece equation. You're substituting X to be 2. So I get 1 over 1 plus square root of 2. So hence, this is a 12 and 1 plus 1 over 1 plus root 2. And let's continue to the leftwards, left side up to -5. So if I go all the way to the left, we will want it to be up to -5. Okay, let's get the same shape drawn out. And I know that the first piece would end at -1. Get the graph repeated. And also at the bottom segment, we have -1. Leftmost endpoint is at -5, 1. Okay, we have completed the graph, but can I write you certain pointers to help you remember what are the features of the graph that you have to get it right? Okay, so the first thing you should know is for such a graph, after you draw in one section, you should draw in these guided dotted lines at the highest and lowest position. Okay, so I write that down, draw dotted. Let me call this as guidelines at highest and lowest. Of each segment that you have, we draw in that guidelines. Number 2, you should indicate whether you are including solid dot or excluding at the end of each segment. Last, if you note carefully, my extreme left and extreme right endpoint of the graph, I indicated the coordinate. So give the coordinate at extreme endpoints. Write in coordinates at extreme endpoints. So that would be a complete graph that we will have for a function that looks like this. Okay, so the last thing I want to talk about before you try out a few questions is how do we get this to be drawn? So can we go to the next page? Let me show you what we should key into the graphing calculator step by step.